Greetings, everyone. Welcome to the second part of the video for section 8.1. Continuing on looking at some ways that we can use the law of sines. So let's take a look at this problem. So we're asked to find all missing information in the triangle given by the following information. So it tells us that the length of side B is 22 centimeters. Length of side C is 28 centimeters, and the measure of angle beta is 37 degrees, which even though I said in the last video that we don't always use A, B, and C, and alpha, beta, and gamma, in this case it looks like they are, so we could probably assume that the side of length B is going to be across from the angle of measured beta. So just like any problem where we're looking at some sort of a real world or at least a physical object, it would be extremely helpful for us here to draw a picture. So we'll go ahead and do that. So I'm going to draw a triangle and label the sides. I'm going to call this A, this B, this C, this angle here alpha, this one here then would be beta, and this would be gamma. Okay. We put in the information we're given. We're told the length of side B is 22 centimeters. We also know the length of side C is 28 centimeters. And the measure of angle beta, this one here, is 37 degrees. Okay, so then we can go about now solving for the missing information in this triangle. So we'll start by, since we have the measure of angle beta, the length of side B, that's good. We know we can use the law of sines because we have an angle measure on the side opposite from it. We also have this side of length 28 centimeters, and we don't know the angle across from it, but we might be able to solve for it based on the information we're given. So let's go ahead and set up a ratio here using our law of sines, which will tell us that the sine of angle beta, which is 37 degrees, over the length of the opposite side, so that side of length 22 centimeters, is going to be the same as or equal to sine of gamma now, the angle we don't know, divided by the length of the side opposite the side of the angle gamma, which is the 28 centimeters length side. And hopefully you can see from this equation we have now, we could go ahead now and solve for gamma. So we'll do that by, first of all, isolating the sine of gamma. So we'll multiply by 28 on both sides. So then we will have 28 times sine of 37 degrees all over 22 equals sine of gamma. And we don't have to do this, but just to make a point, I'm going to find out what 28 times sine of 37 degrees divided by 22 is. Looks like that would give us 0.7659. And so to find gamma then, we know we can take the inverse sign here. Do that up here. So we would do gamma would be equal to the inverse sine of all that mess we have there. So the 28 sine 37 degrees, all divided by 22. Plug that in our calculator. Make sure your calculator's in degrees mode, since we're working with angles in degrees. And so when we do that, we end up with, looks like 49.991 degrees. Okay, so that would be the measure of angle gamma over here. 49.9, oh Lord, 991 degrees. There we go. Okay, now the information we have left to find still is the measure of angle alpha and the length of side A. Now, hopefully you see that because we have the measures of angles gamma and beta, we can now find the measure of angle alpha. reason for that is that we know that if we do alpha plus beta plus gamma, because we're in a triangle, that the sum of those three angles should be 180 degrees. Therefore, we can plug in the information we know. So we know the measure of angle beta is 37. We know the measure of angle gamma is 49.991 degrees equals 180 degrees. If we solve for alpha there, we get the measure of angle alpha is 93.009 degrees. Okay. And now at this point, we are almost done. Okay. We just need to find the length of side A here, which we can again do with the law of sines, because we now know the measure of the angle opposite that. So we can set up a ratio using sine of 93, but that's not 93, that's 39. 93.009 degrees over the length of side A equals, and we could use either combination of the other two angles to solve here, but because we were given the information about beta and B, and the information we have about gamma is a rounded answer, I'm going to use the given information. So sine of 37 degrees, which is the sine of beta over the length of the side B, which is 22. Then we want to solve for A. In order to do that, we first have to multiply by A on both sides to get it out of the denominator. So then we would have sine of 93.009 degrees equals A times sine of 37 degrees all over 22. Hopefully you can see that from here we can multiply by 22 on both sides, then divide by 37. So we get A equals 22 times sine of 93.009 degrees, all divided by sine of 37 degrees. If we plug that in our calculator, then it looks like we would get 36.506 centimeters. And we again have to be careful and make sure that our calculator is in degrees mode. Okay. And now we found all the missing information in this triangle. Sweet, right? Cool. Now, I want to go back to something we did here. Back up here, and we're finding the value of gamma. So we did inverse sine of that 28 sine 37 degrees, all divided by 22, which gave us 49.991 degrees. And if you remember, over here off to the side, I wrote what 28 sine 37 degrees of 22 equals, right? It's a positive, oops, it's a positive 0.7659. If you think about stuff we've been doing the last couple of chapters, which quadrant is 49.991 degrees in? Right, that would be in the first quadrant if we think about a unit circle. Right, so 49.991 degrees is here. And one of the reasons we know that is because we took the inverse sine of a positive number, that 0.7659. Now, is that the only place in the unit circle where sine is positive? And the answer is no, right? There's also values in there, an angle in the second quadrant where the sine would be positive as well. So let's find that angle. And so we know that it would have to have the same reference angle as 49.991, which means it could be found by doing 180 minus 49.991 degrees, which, if we work that out, looks like that would give us 130.009 degrees. And now the question is, could gamma have had that measure as its measure? Well, if we think about the original information we were given, we were also told that the measure of angle beta was 37 degrees. We just found a possibility of gamma being 130.009 degrees. Would it still be possible, if we have that, for there to exist an angle alpha with those two in the triangle? And the answer is yes, right? We can actually find that by doing 180 minus the sum of both of those. And in this case, we would get 12.991 degrees. So what we see here is actually a possibility of a second triangle existing with the same information. Okay, it would still have the length, or sorry, the measure of angle beta being 37 degrees, and the length of side B being 22 centimeters, and length of side C being 28 centimeters. But in this triangle, the measure of angle gamma would be 130.009 degrees, and the measure of angle alpha is 12.991 degrees. Okay, so there'd actually be a second possibility of a triangle. So it's kind of like, if you're fans of the X-Men movies, you know, there's like those parallel sideline storylines where there's like Patrick Stewart is playing Professor X, but then also that other British guy whose name I can't remember also plays Professor X. James McAvoy, is that his name? Something like that. Anyways, there's two kind of parallel stories going on here with the triangle. Okay. Now, I'll also tell you that doesn't always happen. So let's say so we still had the angle beta being 37 degrees, but when we did the trick that we just did to find a second possibility for gamma, we ended up with the measure of that being 160 degrees. Well, is it possible to have a triangle now with angle beta being 37 degrees and angle gamma being 160? And the answer is no, right? Because the sum of those two is 197 degrees, which is now above 180. So in this case, we would not have such a triangle. So we need to make sure we check that when we are solving for angles using inverse sine in the law of sines. Okay. All right, that's it for now. Thank you for watching.